So the next part of 4.2 is honestly one of my favorite topics to talk about because it is so relevant and you see it everywhere. And that's the way that you see statistics being misrepresented in the media. And when I say the media, I don't just mean the news media, I don't just mean social media, I just mean all over. You see this everywhere, whether intentionally or not. It's just all over the place. And the fact of the matter is that no outlet is immune to this. No topic, no media outlet, nothing is immune to this. You will see this everywhere with all topics. And psychologically, even if you know you're being misled, your brain will still try to believe it. Even if you know that something is up, it's really hard to train your brain to not fall for it. So just one disclaimer. A lot of the examples that we see of this revolve around politics, but this is not a political lesson by any means. This is something that we see in non-political examples too, but it happens to be that because a lot of politics involves pushing one narrative or the other, that a lot of the examples that you do see in politics. But this is not a political lesson. Keep your focus away from the source and focus instead on the way the data is being presented. So the first way we can manipulate statistics is by omitting the baseline. And by baseline, I mean if you think about a graph, let me just pick a different color here. If you think about a graph, your axes both start at 0. And even if it's a bar graph, like you have maybe like categories here, your y-axis still starts at 0. To do something other than that is called truncating the graph. Right? Truncating just means to cut it shorter, so you're making the graph appear shorter. And what that can do is actually make a small difference much more pronounced. And it exaggerates what would be a small difference. So case in point, this example here. This is just a sample that's not tied to any real statistics here. But just from looking at it, right, if I just ignore the y-axis for a minute, it almost looks like Democrats agree with Republicans and independents almost 3 times as much. Right, if I were to like take this bar and kind of copy it twice, right, there's almost triple the support with the court for Democrats than Republicans and independents. If we look at the y-axis, that's not really true. Democrats agree about 62% of the time. That's not a good color for this graph. About 62% of the time. Republicans agree about 54% of the time, and so do independents. So there's really only, an 8% difference going on here? Not triple. And sure enough, if we actually draw this properly and scale it down so that the y-axis actually is 0, which is what we don't see here, that difference is more normalized, right? That difference is not very large at all. This is the kind of thing, so maybe depending on what the case was, either side, either bias, could use this in their favor. Say, well, look how much the Democrats support this. This is a great thing depending on what it is, or, oh, this is a terrible thing depending on what that thing is. Another one right from the actual news, right? What's going to happen if Bush's tax cuts expire? And it looks like it's almost probably, 4 times as much, right? This looks like a huge gap. And they're being upfront, right? They are showing you that the y-axis does not start at 0. It starts at 34. But the print is really small. And if you're watching this from afar, you're not really going to see those numbers. Furthermore, they don't leave graphs up on the screen for too long because they don't want you to pick it apart and realize what they're doing. This is not they meaning Fox Business. This is just they meaning media in general. Like, you don't see a graph on the screen for long enough to interpret it. Well, realistically, that says 35%, and this says 39.6%. And I don't know about you, but when I think about a 4% difference, I don't think about this massive gap. I think about something that's much smaller. And again, we bring the y-axis back down to 0. So you want to show that y-axis always starting at 0. This should always start at 0. The next way we can manipulate data is by manipulating the y-axis. So, okay, we can keep the minimum at 0, but we can play with the range and the scale of the y-axis in other ways. So maybe if I'm dealing with maybe a range of test grades and I want to show like 3 students' averages, and I want to show that they're really doing well, but their best grade is a 60. Well, if I set this at 60, it looks like they're doing really well. When in reality, if I were to show this honestly and I were to pick a scale that actually maybe makes sense, you can see that maybe they're not doing too hot. All right, so we can extend or compress the scale of the y-axis, and that's going to either exaggerate or downplay a trend in the data. The giveaway for this is if you notice that there's a lot of blank space or no blank space. If you notice that there's a lot of blank space or if there's no blank space at all, this may have happened. Case in point, we're looking at Arkansas football wins. So if I'm maybe not a fan of Arkansas and I want to show how bad of a team they are, I'm going to use a graph like this. And it still starts at 0, so this is good. We're not truncating the y-axis. But I don't know much about college football, but I do know that they don't play anywhere near 100 games in a season. That is excessive. So it doesn't make sense to use a graph that has all of this blank space. Because, I mean, at most, they probably play, what, like less than 20 games? Like I said, I don't know a lot about college football, but I know they don't play like anywhere near 100 games in a season. This isn't baseball and it's not hockey. Actually, even college hockey doesn't. I digress. But most of the data falls between 0 and 25, so it would be a much better scale to show it up to 25. And sure enough, actually, I can even go less far and show it up to 12.5, right? Depending on how many games they play or how many times they've won, because we're talking about wins, this is a much better graph to show me that, no, they don't just universally suck. They have some good years, right? They've got some good years, and they've got some really bad years, but there's really no trend overall, whereas this is kind of showing a very low trend, and it's not exactly honest. So we want to make sure there's a healthy amount of white space, of blank space here. This is just far too much. The next one is, I think, the one that you see maybe most frequently when we're dealing with just statistics. When we're not dealing with graphs, we're just dealing with numbers. And that's called cherry picking data. So cherry picking, in general, refers to systematically or methodically selecting only specific data points from the larger set. Usually this data is selected in a way that pushes a narrative, right? I'm either wanting to play up my own views or play down theirs, right? I either want to show that my point is good and I'm going to show it in a positive light, or I want to show my opponent's point in a negative way. You see this especially around election season, or just in any sort of political news, but especially around election season. And again, with statistics, it tends to be the case when they display it on the screen on the news, they don't show this long enough for you to pick apart the small print. Like, you don't get enough time to see this or to see this. You just see your eye naturally is going to get drawn to the big red bar. So besides the fact this looks like a bar graph and it's not a faithful bar graph, all we see is approval, 88%. Cool, that's great. That looks really, really good. Actually, I didn't want to change my color. That looks really, really good. You don't have enough time to notice the little fine print up here that says that we're just looking at job approval among Republicans. And, they're good and they're honest and they show you that they did pull their data from somewhere, right? They got it from the Wall Street Journal. They show when they sampled it and their margin of error. But again, you don't have time to read the fine print in the amount of time that they leave this up on the screen for. Well, when we go to the actual poll and see the full results, again, they're being honest. Here is, where is it? Here is among Republicans the group who approve at least somewhat of the president's performance in office, right? And I get the 88% that they talked about, and here's my disapproval, and I get the 9% that they talked about, and that's great. But this is not a representation of the larger poll, because the Wall Street Journal didn't just survey Republicans, they surveyed all registered voters. They broke it down by demographic, but this paints a much more accurate picture of what the sample thinks of the president's approval rating, right? So the approvals are really only, 45% in this poll, and the disapprovals 52%. So we see a lot of this kind of skewing, especially in politics, right? We want to show, in this case, I don't know what station it came from, but we want to show that the president is doing a great job. So we're going to pick this and we're going to display it in a way that your eye gets drawn to the big number and not to the fine print, and certainly not to the rest of the data. And it's all being done to push a narrative. Again, this is not a jab at whatever media source this is. This is just to say this is what you see in the news all the time. Nobody is immune from this. The next method is using the wrong graph. So as a general rule, bar graphs are going to be used to make comparisons between non-numerical categories, right? We saw that with the court thing, right? We had Democrats, Republicans, and independents. So these are non-numerical categories, and it makes sense to say, here's the thing, here's the percent of these guys, here's that percent. Line graphs are used to make comparisons over time, right? So if I want to look at 2019, 2020, and 2021, it makes more sense to show that over time, show that trend, that change over time. Pie charts are used to show how categories fit into a whole. So if I wanted to look at maybe election results, a pie chart would be a great case for that. I can show candidate A, candidate B, and candidate C, and I can see how the election kind of shook out. The total of a pie chart should always be 100%. Statistically, there is a margin of error. So even if you're like 99 to 101, like because of margin of error and rounding, that's good, that's okay. But you should definitely not have like the total of the pie chart being 80%, and you certainly should not have the pie charts representing non-proportions, non-percentages. So let's look at some examples here. This is different than the one you have in your notes, but that's okay. I'm going to talk about the one in your notes separately because it is particularly terrible. But here's an example of definitely using the wrong graph for a lot of reasons. One, first rounders in the common era by school. We're not talking about a specific division. We're not talking about a specific draft by school. So use a different color here, by school. That's great, but like, what about other schools? Are we talking about a specific division? They don't say that. Are we talking about a specific conference? This is not of a proportion, right? This is not first rounders of all of the schools that have had first round draft picks. This is based on somebody that doesn't have a lot of background knowledge. This is a comparison of 5 schools, which is not great for a pie chart. So there are no proportions here. Unclear sample, right? Again, we don't know where this is coming from, but also the proportions anyway are disproportionate. Unequal or unfair sizing, right? 69, I need a better here. A wedge of 69 should be fairly close to a wedge of 64. A wedge of 47 and a wedge of 49 should be even closer together. This is the biggest issue here. These should be a lot closer in size. Besides the fact this is the wrong graph altogether. The better one would be a bar graph, right? You have non-numerical categories and you want to make a comparison between the 5. Again, I think they could still be more clear and they could still say most players drafted from fill in the blank conference in the first round. But this makes it a lot clearer, right? This is an abomination. This is just atrocious. Speaking of, kind of actually going hand in hand because choosing the wrong graph does have an impact on our conventions. As a general rule, color means a lot in our heads, right? Color associations are huge. So in politics, especially, we associate blue with Democrats and red with Republicans. If I flip that, that's really confusing, which is why a lot of times, even if something is not meant to be a political statement or a political graph, but the topic might be viewed as political, you'll see a lot of graphs and a lot of presentations avoid blue and red altogether. Furthermore, darker colors and heavier shading imply more of something. So if you think about this past election, if you think about the election map, some charts, some graphs showed varying shades of blue for how many people voted for Joe Biden, and likewise varying shades of red for how many people in a particular county or state voted for Donald Trump. So this implies a heavier density, right? The lower you go, the more, or the darker you go rather, the more people voted for that candidate. Green tends to represent something positive, a gain or a loss, a gain or a profit. Again, it can be really disorienting to see these conventions flipped as you see here. This is bad. This is terrible. Because my credit score is not good. This is a good credit score, but it's shown in red, which makes me think it's bad. And this is a terrible credit score, but it's shown in green, and my gut reaction is, hey, that's actually pretty good. So the best thing to do with this graph is to just invert the color scheme. And just misusing color in general can be unconventional and can also be confusing. Using colors for no reason, changing the shading of things can all be confusing as well. So this was one of the longer videos for sure, but there's a lot of really important and real world information here. So we want to be really careful when we're looking at these graphs, and we want to make sure we're reading them critically. We're not just taking the information at face value.